All right, let's talk about mastering AI. Today, we're going to map out the entire journey, and we're not just going to list a bunch of definitions. We're taking a peek behind the curtain of a full-blown master course. We'll use its structure as our guide, kind of like a blueprint for how you can build real expertise from the ground up. Okay, let's get right into it.
So, here's our plan. We're going to kick things off with the absolute bedrock, the AI foundation. Then we'll jump into how AI actually learns from data with machine learning. After that, we'll upgrade to the supercharged deep learning engine. And finally, we'll see it all in action, looking at AI that can understand our language and even AI that can see and act in the real world.
You know, you can't build a skyscraper without a solid foundation, right? Well, AI is exactly the same. Before you can get to all the cool, advanced stuff, you have to nail the core concepts that everything else is built on. So let's get our hands dirty and start with the basics.
So when people throw around the term AI, what do they actually mean? Well, when you boil it all down, it's this incredible mission to build computer systems that can do things that usually require a human brain. You know, stuff like logical reasoning, solving tricky problems, and maybe most importantly, learning from experience. And here's something that's super important to get. Mastering AI is so much more than just coding. It's this whole mix of different fields. To really build something smart, you need the theory, the math behind it, how it's used in the real world, what's happening in research, the whole shebang. It's about building the big picture in your head, not just learning a single skill.
Okay, foundation set. Now, let's get to the engine that powers pretty much all the AI you interact with every day. This is where things get really interesting, because this is where the magic of learning from data really begins. Let's talk about machine learning.
Okay, so here's the absolute key idea. Imagine trying to teach a kid what a cat is. With old school programming, you'd have to write down every single rule. It has pointy ears, it has whiskers, it has a tail. It would be impossible. With machine learning, you just show it a bunch of pictures of cats. That's it. It figures out the patterns and makes the rules all by itself.
You know, to really drive this point home, let's look at a question you'll almost definitely see in a tech interview or on an exam. If you can really nail this distinction, you're golden. It's totally fundamental to understanding AI today.
And this just lays it out perfectly. Look, on one side, with traditional programming, you give the computer the input data and the program, the rules you wrote, and it spits out an answer. But on the other side, with machine learning, you give it the input and the answers you want, and the computer's job is to figure out the program for you. It literally writes its own rules. That's a total game changer.
Okay, so we have this amazing machine learning engine. Now, what if we strapped a rocket to it? That's basically deep learning. This is the high-octane powerhouse behind all the biggest breakthroughs you hear about, from things like ChatGPT to those incredible AI image generators. So deep learning is a type of machine learning, but it takes things to a whole new level. It uses these things called artificial neural networks, which are kind of modeled after our own brains, with all these interconnected layers. And because it has so many layers, because it's deep, it can find these tiny hidden patterns in huge data sets that we as humans would never be able to see. This diagram shows it perfectly. On the left, you feed it your input data, let's say a ton of cat photos. In the middle, that data flows through the network. The first layer might just spot simple edges, the next layer sees whiskers, the next layer puts those together to see a nose, and it keeps getting more complex until, boom, out the other end comes the prediction. That's a cat. So you can really see the evolution here, right? It's beautiful. We went from us humans telling the computer the rules to the computer learning the rules all by itself from data. And now, with deep learning, the computer learns those rules on a level of complexity that's just, well, it's on another planet.
All right, we've built our super powerful engine. Now for the fun part. Let's see what it could actually do. And first up, we're going to tackle something that's at the very core of being human, language. Let's talk about natural language processing.
So NLP, or natural language processing, is basically the bridge between our human languages and the computer's language of ones and zeros. It's all about teaching machines to read, understand, interpret, and even write just like we do.
And here's the thing, you use NLP every single day, probably without even thinking about it. Asking Siri or Alexa a question, that's NLP. Using Google Translate on a menu, NLP. The autocorrect on your phone saving you from embarrassing typos, yep, that's NLP too.
Okay, so we've given AI a voice. Now let's give it eyes and hands.
For our last big topic, we're diving into how AI sees the world with computer vision, and then how it actually acts on what it sees with robotics.
I love this way of thinking about it. If NLP gives a computer ears and a voice, then computer vision gives it eyes. Think about your phone unlocking just by looking at your face, or a self-driving car spotting a stop sign. That is all computer vision at work. And look, you're probably starting to see the pattern here, aren't you? It's that same core idea. You take some input data, this time an image or a video, you run it through a powerful model, and you get a useful output, like identifying every person and car in the scene. Simple as that.
And this is where everything we've talked about comes together. Robotics. It's like taking the machine learning brain and the computer vision eyes and plugging them into a physical body so it can actually do things out there in the real world.
This diagram shows that final, incredible piece of the puzzle. The input comes from sensors, the algorithms make the decisions, and the output, well, it's not just a number on a screen anymore. It's a real-world action. A robot arm moves, a car turns, a drone changes course. That's the leap.
So that's our journey. We went from the absolute basics of AI all the way up to intelligent machines that can see, talk, and interact with the world around them. We've laid out the entire roadmap to mastering AI. But it's more than just a list of topics, right? It's a toolkit, a seriously powerful one, and it can be used to solve some really big problems. So the real question left is, what are you going to build with it?